to the next example. Of course, I'm going to be very brief in this one. This example is already been meshed and calculated, so we are just going to do a quick overview and get to the results. So this is, again, another fluid dynamics analysis. In this case, it's a 3D with a volume. As you can see, it's just the half of the geometry. We are going to take advantage of the symmetry. And it's a body of a valve. In this case, we have, as working fluid, we have air at a certain temperature, in this case 50 degrees Celsius, and the boundary conditions, in this case, we have divided them into two bodies. I'm going to draw them so you can see them. You can see a boundary has been set for the valve, and another boundary, different boundary, has been set for the wall. In this case, this is just for comfort for the analyst, because the wall is the same. It's the same condition. It's a Y plus wall. In this case, the boundary layer is not solved numerically, like in the previous case, in which we had the boundary layer. In this case, the boundary is going to be solved analytically with a law of the wall, and both are the same, but we separated them into different boundaries because we want to integrate the force and the pressures and get the forces over both of the walls separately. So if you see the forces graph that we saw before with the other model, as you can see, there are two tabs here. So we'll have the pressure, the forces, the integrated pressures on the boundaries for the two of the walls. So we have both results. Have two sets of results for each boundary. So this can be really useful. And regarding the boundaries, they are quite straightforward. We have an inlet here. It's a velocity inlet, and 10 meters per second. The air is entering into the domain. And we have an outlet, and in this case we have set a pressure outlet with a certain value up here. Okay, and what else we can see here? In this case, the symmetry has not been imposed with a velocity condition explicitly, but with a condition, with a plane of symmetry, which is the same at the end, but is a little bit more easier to apply here. We just set the coordinate of the symmetry plane here, and it works as same as the other condition. Regarding the mesh, we can see it. We are not seeing the volume mesh, just the surfaces. So you can check on the mesh over the valve and in the walls. And we could go directly to the post-process. And basically there are the same results because we haven't done anything special, just as it's a 3D example, so you can see both of them. So we have the velocity contour field. You can see an animation of the results. Okay, evolution of the velocities inside the domain, and of course we could do the same with the pressure. See a map of the pressures, and observe the evolution inside the domain. Of course, there are other useful tools. For example, we could do a cut on the geometry, so we can see the insides of the of the valve in another plane. We have to check the CAD options here, see in the preferences of the post-process. And we are going to perform plane cut in the screen. So just drag the pointer and we have the cut. As you can see, the rest of the geometry has remained, but in a transparent view, but we could deactivate them and just activate the chosen plane in which we want to see some results. Because here we could see some other local, for example, the vectors here in this plane. And well, I think this is pretty useful. So, well, I think I have exceeded a little bit my allowed time, so I don't want to bore you any much more. Hope that you have found this webinar interesting. And of course, feel free to send me any question, any inquiry to my mail, and visit our website. Of course, you can download the software freely for a 3 months trial, so you can check all the tools and see if they suit for your applications. And well, that will be it. Thanks a lot for attending, and have all of you a really nice evening, and goodbye.